Good morning to all. Today we are going to discuss about that oxides of halogen. So page number 90. Our lesson is about that P block element 2, that is unit 3, oxides of halogen. All of you know that one. What are halogens? Fluorine, chlorine, bromine, iodine, these are all as a halogen. Halogen. Halo means salt. Okay, what is the meaning of halogen? Halo means salt. Gen means forming. So, salt forming, that is called as a halogen. The 17th groups elements are called as salt forming groups. Salt forming elements. It is involved for the salt forming, for example, chlorine, sodium chloride, potassium chloride, sodium bromide, potassium bromide, sodium iodide, these are all salt, okay, by means of an alkali element. Here, we are learning about the oxides of halogen. That is, one of the halogen combines with oxygen to form oxides of halogen. Fluorine reacts readily with oxygen. One of the fluorine readily reacts with oxygen to form difluorine oxide. Difluorine oxide formula F2O, difluorine oxides, and also difluorine dioxide, difluorine, that is F2O2, difluorine dioxide, where it has a -1 oxidation state. All of you know that one, -1 oxidation state. Previously we discussed how we can find out the oxidation state. But the other halogen, except fluorine, the other halogen do not react with oxygen readily. Fluorine can readily react with oxygen, but other halogen, that is about the chlorine, bromine, iodine, these are all do not react with oxygen readily. Here, some of the oxides, some of the oxide can be prepared by some indirect method. We are using some of the indirect method. Except fluorine, all other halogen have positive oxidation state. The fluorine only have the negative oxidation state. Except fluorine, other halogen, maybe chlorine, bromine, iodine, these have the positive oxidation state. Dear children, please look the page number 90. They have one tabular column. They have explained about the types of oxides of types of oxides of halogen. Here having 5 types. What are the 5 types means? X2O, XO2, X2O5, X2O6, X2O7, and also having this also having. So here X2O, XO2, X2O5, X2O6, and X2O7. We have to find the oxidation state. Many times we discuss about the oxidation state. Just we can recall that oxidation. How can you find the oxidation state of X2O molecular formula compounds? One of the compound having the molecular formula X2O. We know that the halogen, all the halogen having -1 oxidation state. Am I right? Here we are taken as X2 means we can be taken as 2X plus oxygen is a -1. Okay, it is always oxygen atom always having -2, not -1, -2. Don't forget that, it's always -2. So 1 into -2 equal to 0. 2x plus 1 into -2 equal to 0. 2x minus 2 equal to 0. X is equal to 2 by 2 equal to, we can written as 1. oxidation, plus 1 oxidation state. What about the SO2? SO2, XO2 can be written as, how can you find the oxidation state SO2? X we are taking as X, 2 oxygen having 2 into minus 2 equal to 0. X minus 4 is equal to 0. X is equal to plus 4 oxidation state. What about the X2O5 oxidation state? X we are considered as a X, 2X plus 5 into minus 2 equal to 0 because oxygen having minus 2. So 2x minus 10 is equal to 0. X is equal to 10 by 2. X is equal to plus 5 oxidation state. The next molecular compounds, X2O6. How can you find that X2O6? Here having X is 2. So we can be taken as 2X plus oxygen having minus 2. 6 into minus 2 equal to 0. 2x minus 12 equal to 0. X is equal to 12 by 2 equal to plus 6 oxidation state. Next the compound is X2O7. How can you find the X2O7 oxidation state? Here having 2 halogens, so making as 2x plus oxygen having 7, 1 oxygen having minus 2 equal to 0. 2x minus 14 equal to 0. X is equal to 14 by 2. X is equal to plus 7 oxidation state. The other also having, let us begin to discuss. My dear children, first we are going to learn about that fluorine, one of the halogen fluorine. All of you know that one. Fluorine is the most electronegative element among halogen. It is also a small size, am I right? Here, except fluorine, others can form oxides of halogen, except fluorine. Okay, except fluorine, other halogen, that is chlorine, can form oxides of halogen. Bromine can form oxides of halogen, and iodine also can form oxides of halogen, except fluorine. Fluorine cannot form the oxides of halogen. That means it cannot form X2O compound, XO2 compound, S2O5 compound, S2O6 compound, or X2O7 compound. It cannot form. Okay, can you understand, my dear children? Except fluorine, other halogen can form, but fluorine can form other type. Other type means we can say that one OF2. The oxidation state is a -1. We can find that one. Then also other one O2F2, and one more O4F2. These are the three different types of other compounds can be formed by fluorine. Fluorine never formed the H2O, SO2, S2O5, S2O6 and S2O7, but it can form OF2, O2F2, O4F2. These are some compounds. What is the name of the compound? OF2. Oxygen fluoride, OF2. What is the name of the compound? Oxygen fluoride, OF2. What's the next one? O2F2. That is about the dioxygen difluoride. The last one is O4F2. Tetraoxygen difluoride. Okay, these are some compounds. Next, we can discuss about that Cl, about the second halogen, Cl, chlorine. Chlorine can form S2O type and Chlorine can form SO2 type. Chlorine never form S2O5. Don't forget that. It's one of the one-word question. Chlorine, halogen chlorine never form S2O5. Chlorine can form S2O6. Chlorine can form S2O7. And also other type also chlorine can form Cl2O4. Cl2O4. So chlorine can form X2O, XO2, X2O6, X2O7. Okay. So what are the examples? X2O, the example is Cl2O. SO2, the example is ClO2. S2O6, the example is Cl2O6. X2O7, the example is Cl2O7. And other also Cl2O4. The oxidation state you have to find out. Okay. Dear children, for the one-word question, they will ask about the one-word. Try to learn this name of the compound. Cl2O, what is the name means? Chlorine monoxide. Chlorine monoxide. Please mention that one. I will ask the question. Chlorine monoxide. What is ClO2? Chlorine dioxide. Chlorine dioxide. What is Cl2O6? Chlorine hexaoxide. Chlorine hexaoxide. What is about that? Cl2O7. Chlorine keptaoxide. Chlorine keptaoxide. Next, Cl2O4. Chlorine tetraoxide. Chlorine tetraoxide. Don't forget that, dear children. Please learn these formulas. Okay. Next about that. Next to halogen is about that. Bromine halogen. Bromine also can form the type X2O, X2O3. But bromine cannot form this type X2O5, X2O6 and X2O7. Bromine cannot form this compound X2O5, X2O6 and X2O7. Clear? Next, it cannot form the other type also. Bromine cannot form the other type also. So next we can be the example. What are the examples of bromine? Here, type X2O. The example is Br2O. Br2O. Can you say the name of the compound? Bromine monoxide. Bromine monoxide. This is an example. Br2O. Bromine monoxide. Next about the type XO2. I am writing one of the examples. BrO2. BrO2. Bromine dioxide. Bromine dioxide. Okay. The last halogen we can be discussed. Iodine. Dear children, iodine also cannot form S2O, XO3, X2O6 and X2O7. Iodine can form only one oxides of halogen. Iodine can form only one type of oxides of halogen. That is only X2O5. One of the very important one-word question. X2O5. So what is the example here? I2O5. I2O5. The name of the compound. Iodine pentaoxide. 5 means penta. Iodine pentaoxide. And also iodine can form other oxides. Oxides of halogen. For example, I4O9, one of the very important one word. I4O9, I2O4, I4O9. Next one, I2O4. Here 9 means all of you know that one. Nano, am I right? That we are saying. What's the name of the compound means? No, that is NONA. No. Oxido. Name of the compound. Please mention that one. No. Oxido diiodate. Nona. Oxido diiodate. What is the name of the next compound? I2O4, iodine tetraoxide. Iodine tetraoxide. Okay, please learn these questions. Next about, we can be discussed oxo acids of halogen. Oxo acids of halogen. These are the important area how to learn. Oxo acids of halogen. This is how it is forming means all halogen, maybe a fluorine, maybe a chlorine, maybe an iodine or bromine. This one combines with oxygen and also hydrogen, we get oxo acids of halogen. Here chlorine, I am speaking about the chlorine. First, we are taking chlorine. Chlorine can form different types of oxo acids. Here, first we have to learn about the type. What are the type here? Types are considered as the four type. One is HOX. Second one is HXO2. Third one is HXO3. Fourth one is HXO4. These are the types. What are the types here? HOX, HXO2, HXO3, HXO4. Here, what is about the X? X refers as whether it may be a fluorine or chlorine or bromine or iodine, like that. X. Dear children, before that we have to learn what are the types, what are the common names, what are the common names of oxo acids of halogen. I am giving four common names. One is about that hypohalous acid. Second one, halous acid. Third one, halic acid. Fourth one, perhalic acid. Can you clear? What are the common names? Four common names. First one, hypohalous acid, hypohalous acid, halous acid, halic acid, perhalic acid. Okay? Hypohalous acid, halous acid, halic acid, perhalic acid. These are the four common names. And also many times we discussed that how to find the oxidation state. If you feel any difficulty, please ask me, I will help you, okay? The oxidation state of the first type, HOX, that is +1. Hypohalous acid, the example, +1. Next about HXO2 is +3 oxidation state. HXO3 +5 oxidation state. HXO4 +7 oxidation state. Okay, have any doubt, my dear children, for finding the oxidation state? If you have any doubt, please ask me. Okay, so before that we can be fine. What are the different forms of chlorine? Chlorine can form 4 different oxo acid. The first one is hypochlorous acid. Second one, chlorous acid. third one chloric acid, fourth one perchloric acid. So before that I am studying fluorine, okay. So and also bromine and iodine form similar acid except Halous acid. Halous acid cannot form, okay, because Halous acid is only one, it is about only for chlorine. Chlorine can form 4 different forms of an acid. Here bromine and iodine form a similar acid except Halous acid. Fluorine can form only one acid, that is called fluoric acid, hypofluoric acid. And also we can learn about that oxidizing power. Oxidizing power. How can you find the oxidizing power? First you have to write the types. What are the types we learned today? HOX, HXO2, HXO3, HXO4. These are the 4 types. Here hypohalous acid, there is a HOX, hypohalous acid, HOX, hypohalous acid, that have only one oxygen. Second, halous acid, it contains 2 oxygen. Halic acid, it contains 3 oxygen. And perhalic acid, it contains 4 oxygen. Don't forget that. Hypohalous acid contains how much oxygen? Only 1 oxygen. Halous acid containing 2 oxygen. Halic acid containing 3 oxygen. Perhalic acid containing 4 oxygen. The first one is the hypohalous acid. The oxidizing power of hypohalous acid is greater than halous acid. The halous acid oxidizing power is greater than halic acid. The halic acid oxidizing power is greater than perhalic acid. So don't forget that for the one-word question. Perhalic acid, the oxidizing power is very small, okay, very low, very small, okay, don't forget that. Next, come to the examples. What are the examples of oxoacids of halogen? First, I am taking fluorine. The fluorine have only one oxoacids of halogen. Don't forget that. Fluorine have only one oxoacids of halogen. That is first one. Type HOX. HOX type. It cannot form HXO2, HXO3, HXO4. It can form HOF. The name of the compound is hypofluorous acid. What's the name, my dear children? Hypofluorous acid. Hypofluorous acid. HOF. HOF. What about the chlorine? The previous I told that chlorine can form 4 different forms of oxoacids of acid. The first one is type HOX. HOX. Chlorine can form HOCl. HOCl. The name of the compound is hypochlorous acid. Hypochlorous acid. The second type, HXO3. The name of the compound. First we have to write the formula HClO2. Just we are adding one oxygen atom. That much, okay. Just we are adding one oxygen atom. HClO2. The name of the compound is chlorous acid. Chlorous. HClO2. I will ask the question. Please carefully watch the video. Okay. The next one is HXO3. HXO3. The formula is HClO3. Just we are adding one oxygen atom. HClO3. Chloric acid. Chloric acid. The last one is HXO4. The formula is HClO4. HClO4. Perchloric acid. Perchloric acid. So, chlorine only can form 4 different of oxo acids. 4 different oxo acids. Okay. Next one. Bromine and iodine can form only 3 types. That is, one is HOX, HXO3, HXO4. Bromine and iodine cannot form HXO2 type. Chlorine and bromine cannot form HXO2 type. Okay. So, first write the first type HOX for bromine. I am writing the formula HOBr. HOBr. Name of the compound is hypobromous acid. What's the name? Hypobromous acid. Bromine cannot form HXO2. Bromine can form HXO3. That is HBrO3. HBrO3. What's the name? Bromic acid. Bromic acid. The last one, HXO4 type. The compound is HBrO4. HBrO4. Perbromic acid. Perbromic acid. Next, we can discuss about the iodine. Iodine also not formed HXO2. It can form the remaining 3 types. That is the first one, HOX. Iodine can form HOI. HOI. What's the name? Hypoiodous acid. What's the name? Hypoiodous acid. Iodine cannot form HXO2. Iodine can form HXO3. Example is HiO3. Iodic acid. HiO3. Iodic acid. The last one is HXO4. The formula is HiO4. HiO4. Periodic acid. Dear children, here as per the common name, hypohalous acid, and also have the halous acid. Am I right? They're having 2 types. Here having 2 types. One is further, that is us acid. Can you understand? Us acid. What is us acid? Hypohalous acid, halous acid. This us acid, there are 2 types. One is hypohalous acid, another one is a halous acid. Here, this us acid having lower oxidation state, that is about the +1. Lower oxidation state, you have to say the name hypo. Hypo means lower oxidation state. That's a one-word question. Hypo means what? Lower oxidation state +1. Out of this us acid, 2 us acid having, one is a hypohalous acid, another one is a halous acid. Hypohalous acid means oxidation state is +1, that is a lower oxidation state. Next one, ic acid and perhalic acid. Perhalic also ic acid. Am I right? They are having 2 types of ic acid. One halic acid is +5 oxidation state. Another one, perhalic acid, +7 oxidation state. This ic acid having higher oxidation state, that is about the +7, higher oxidation state. So higher oxidation state comes, so we are using per. Don't forget that. Per means higher oxidation state. Okay. Per means what? Higher oxidation state. And hypo means lower oxidation state. Okay. Don't forget. Okay. Next, we can discuss about group 18 inert gas element. Group 18 inert gas element. Here, inert gas means group 18 element, otherwise called noble gas, otherwise called as a rare gas. What is about the occurrence? Noble gases occur in atmosphere. That is helium, neon, argon, krypton, xenon, radon, everything. Am I right? Here, noble gas element, about the physical properties, the noble gas element, their atomic radius and their boiling point is increases from helium to radon. Just we are discuss the tabular column. After that, we can find that one. Okay. Next, about that ionization energy. Already we learned about the ionization energy. What is about the ionization energy? The amount of energy required to remove most loosely bound electron in a gaseous state, that we are saying ionization energy. But here, the first ionization energy decreases from helium to radon. First ionization energy. What is the meaning of first ionization energy? The amount of energy required to remove the most loosely bound first electron in the gaseous state. Removing first electrons, that we are saying first ionization energy. Here, the first ionization energy decreases from helium to radon. All of you know that one. Noble gas have largest ionization energy to compare the other element. What's the reason? Because they are completely filled in the outer orbital or outermost shell. For example, I am taking neon. What is the atomic number of neon? Atomic number of neon is 10. The first shell we can accommodate 2 electrons. Second shell we can accommodate 8 electrons. So outermost shell 8 electron is completely filled. What about the argon? 18. Atomic number is 18. First shell we can accommodate 2 electrons. Second shell 8 electrons. The third shell also 8 electrons. Such a way that we can accommodate the valence electron having 8 electrons. So this noble gas are extremely stable. They are extremely stable, and they have a small tendency to gain or lose electron. Most probably it cannot be lose or gain electron. Am I right? The tendency, a small tendency to gain lose electron. Here we can see some of the physical properties about the noble gas. Except helium, we are not mentioned the helium. We are mentioned only except the helium, neon, argon, krypton, xenon, radon. These are all, everything are the gas only, but we are not mentioning the helium. Okay. So these are all what? Gas. Atomic number, all of you know that one. Atomic number, neon 10, argon 18, krypton 36, xenon 54, and radon 86. These are all about the atomic number. And about that isotope, neon, argon, krypton, xenon having a single isotope. Just here comes to the radon. Radon having 3 isotopes. Don't forget that. 3 isotopes. They are radon 211, radon 220, radon 222. These are the 3 isotopes. Next about the atomic mass. Atomic mass also increases from top to bottom. Am I right? Atomic mass, you have to mention there. You have to learn that one. Next about the electronic configuration. Electronic configuration also we thoroughly learn. Am I right? The first year we learn it thoroughly. If you have any doubt, please ask me about the electronic configuration. And also the atomic radius. Atomic radius also increases to neon to argon. Neon to argon. It is increases atomic radius. Density value also given as an 10 raised to minus value. 10 raised to minus value. About the density, also you should be learn about density. What's the density given for the neon to radon? Next about the melting and boiling point. Melting point or boiling point is all everything are the theoretical value. Melting and boiling point also increases from neon to radon. Melting point increases to neon to radon. Okay. Next about the boiling point. What are about the boiling point? Boiling point is also increases from neon to radon. Neon to radon. Okay, my dear children. Anyhow, today I am giving one of an assignment. What is about the assignment means? Please write the oxoacids of halogen. Oxoacids of halogen. Just to write their types only. Okay, you have to write the what are the types of oxoacids of halogen. Fluorine having single type, chlorine having 4 types, and bromine and iodine having 3 types. This is our assignment. Oxoacids of halogen. Oxoacids of halogen. Okay. Anyhow, please all of you write the assignment. Thank you all of you. Thank you. Have a nice day.